In this video, we look at this indefinite integral, the integral of the sine inverse of 2x plus 2 divided by the square root of 4x squared plus 8x plus 13. So the answer to this integral is on the right hand side, that is here. So if you want to make sure you try this integral before you follow the steps in the video. So I'm going to break this one step by step for us to understand. So I'm going to start off by, I'm going to let theta to be equal to this guy here, that is the integrand. So the sine inverse of 2x plus 2 divided by the square root of 4x squared plus 8x plus 13. So let theta to be equal to the integrand, right? And I'm going to take sine on both sides, so that is going to be sine of theta on the left hand side is equals to sine of the sine inverse. So I'm just taking sine on both sides of the integrand. So sine of the sine inverse of 2x plus 2 divided by the square root of 4x squared plus 8x plus 13. So when we do that, what do we have? We have sine of theta on the left hand side to be equal to, this will cancel that, right? And that is going to be left with 2x plus 2 all over the square root of 4x squared plus 8x plus 13. Right, so this is what we have. Sine of theta is equal to 2x plus 2 divided by that. And from geometry, let's draw a right triangle here, right, with a right angle here, with our angle here theta, right? If we have theta to be this angle, what is going to be the sine of theta? So the sine of theta is opposite over hypotenuse, right? So this is opposite, so the opposite to the angle is this line, that is this line here. So the opposite is 2x plus 2. And the hypotenuse is always a line opposite to the right angle. So this is the hypotenuse. And the hypotenuse is the square root of 4x squared plus 8x plus 13, like this. That's the hypotenuse. So we have to find the adjacent here. Right? So in finding the adjacent, we can use the Pythagorean theorem, which says that, so we can call this one a, which is the adjacent. So we have a squared plus the opposite squared, that is 2x plus 2 squared, and that is equals to the square of the hypotenuse. The square of the hypotenuse, that is 4x squared plus 8x plus 13, all this one squared. This is from the Pythagorean theorem. The sum of squares of the adjacent and the opposite is equals to the square of the hypotenuse. So this is a squared plus, foiling this one is going to be 4x squared plus 8x plus 4. That is foiling this guy. Is equals to the square of that. This one will cancel the square root and we have 4x squared plus 8x plus 13, right? So this 4x squared will cancel the 4x squared. 8x is going to cancel 8x, and then we have a squared plus 4 will be equal to 13. So that implies that a squared is equals to 13 minus 4, and that is equals to 9. So that means a is going to be equal to the square root of 9, which is 3. So the adjacent here is equals to 3. Now that we know the adjacent, we can find tan of theta, right? So tan of theta, we can find tan of theta. We know that tan of theta is opposite over adjacent. The opposite is 2x plus 2 and the adjacent is 3. So this is tan of theta. So if we know tan of theta, then theta here is going to be the arctan or the tan inverse of 2x plus 2 all over 3. So that is it. So theta is going to be the tan inverse of 2x plus 2 over 3. The same theta is the sine inverse of this guy, and that is our integrand. So if we have theta to be equal to the tan inverse of 2x plus 2 all over 3, and the same theta to be equal to the sine inverse of 2x plus 2 all over the square root of 4x squared plus 8x plus 13, then it implies that tan inverse, it implies that the sine inverse of 2x plus 2 all over the square root of 4x squared plus 8x plus 13 is equal to the tan inverse of 2x plus 2 all over 3. So that's what it means. So theta is equals to this guy, which is our integrand. The same theta is going to be equal to the tan inverse of 2x plus 2 over 3. So that implies that these two terms are equal. So we can just replace our integrand with the tan inverse of 2x plus 2 over 3. So our integral is the integral of the sine inverse of this. So that implies that we have our integral I is the integral of the tan inverse. So instead of the sine inverse of this, which is our integrand, we can just write the tan inverse of 2x plus 2 all over 3 dx, because they are the same. And now here we can do a u sub. So let's do a u sub here. So we can let u to be equal to 2x plus 2 all over 3. So that implies that du over dx is what? 2 over 3. So that implies that du is 2 over 3 dx, and then dx to be equal to 3 over 2 du. So we can take our integral from the x world into the u world. So I is going to be the integral of the tan inverse of 2x plus 2 over 3, that is u. And then dx is the same as 3 over 2 du. And that is going to be 3 over 2 outside the integral of the tan inverse of u du. Now our integral has been reduced to this, and now we can do integration by parts. So integration by parts, I'm going to differentiate and integrate something. So I'm going to differentiate the tan inverse of u, and what is left is just 1 du. So I'm going to integrate 1. So this is plus, next is minus. Differentiating tan inverse of u is 1 all over 1 plus u squared, and integrating 1 in the u world is u. And what we normally do, we multiply diagonal terms. We don't need to take the integral, but when we multiply terms horizontally, we have to take the integral. So we can take our integral still in the u world. So our integral I is 3 over 2. Then integration by parts, multiplying terms diagonally, that is going to be u tan inverse of u minus, that is this guy, the integral, because I'm multiplying terms horizontally, that's going to be u over 1 plus u squared du. This is our integration by parts. So I is 3 over 2 u tan inverse of u minus, I am going to multiply this one by 2 and divide the integral by 2. And now we see that the differential of the denominator here is just the numerator. So that is just equal to the ln of the denominator. And it's positive, so we don't need to put it in absolute value terms. We are done, we put the constant of integration. But what is the value of u? U is 2x plus 2 all over 3. We can just replace that. So I is 3 over 2. U is 2x plus 2 all over 3. And tan inverse of u, that is 2x plus 2 all over 3. Minus 3 over 2 times 1/2, that is going to be 3 over 4. And then the ln of 1 plus u. So u is 2x plus 2 all over 3 by squared, and that is u squared, plus the constant of integration. So this 3 will cancel this 3, and then I is going to be equal to, you can factorize 2 out of here, and that becomes 2 into x plus 1 divided by 2. Then tan inverse of 2x plus 2 all over 3 minus 3 over 4. The ln of what? This is 1 plus squaring this one. This is going to be 4x squared plus 8x plus 4 all over 3 squared is 9, plus the constant of integration. So I is going to be equal to, this cancels that, and you have x plus 1 times the tan inverse of 2x plus 2 all over 3 minus 3 over 4. And then what? 3 over 4 ln. So multiply 9 out, that becomes 9 plus 4x squared plus 8x plus 4 all over 9 plus the constant of integration. But we know that tan inverse of 2x plus 2 over 3 is the same as the sine inverse. That is our integrand. We know that from here. The tan inverse of 2x plus 2 over 3 is the same as the sine inverse of 2x plus 2 all over this. So that is our integrand. So this one here is just our integrand. So we just replace that. So I is going to be x plus 1. Instead of tan inverse, I'm going to write sine inverse of 2x plus 2 all over the square root of 4x squared plus 8x plus 13, like this, minus, this is 3 over 4 ln of 9 plus 4, that's 13. So this is 4x squared plus 8x plus 13 all over 9 plus the constant of integration. So I can simplify it further. X plus 1 sine inverse of our integrand. This is just our integrand, which is 4x squared plus 8x plus 13 minus, using the laws of logarithm, this is 3 over 4 ln of 4x squared plus 8x plus 13, and then minus, okay, 3 over 4, and then the ln of minus 9. So this is going to be 3 over 4, the ln of this guy. So I can clean this up. So 3 over 4, the ln of this minus the ln of 9, like this, plus the constant of integration. That is using the laws of logarithm. So I is going to be x plus 1 sine inverse of 2x plus 2 all over the square root of 4x squared plus 8x plus 13 minus 3 over 4, the ln of 4x squared plus 8x plus 13, and then plus 3 over 4 ln of 9 plus the constant. But this one is also a constant plus a constant, so you have another constant, so you can call that k if you want. So this is x plus 1, the sine inverse of 2x plus 2 all over the square root of 4x squared plus 8x plus 13 minus 3 over 4 ln of 4x squared plus 8x plus 13 plus a bigger constant of integration. So these ones can be classified into one constant. So this one is the answer to the integral. So when we go back up, providing the answer at the very beginning here, this one conforms with the answer in the beginning. So this is the answer to our beautiful integral. So that is how to solve this kind of integrals. If you have an easier and faster way to solve it, leave a comment in the comment section and let me know what you think. Anyway, I thank you so much for watching this video. Please subscribe to Calculus Diaries for more content, and I will see you in the next one. Bye bye.